The following question has appeared in JEE 2012 exam. The question is as follows. An infinitely long cylinder of radius r has a uniform volume charge density rho. It has a spherical cavity of radius r by 2. So this is a cylinder, a solid cylinder with charge density as rho, and it is infinite in length. And from this cylinder, we remove a sphere of radius r by 2. This cylinder has a radius r and this removed sphere has a radius r by 2. So there is a cavity over here. The magnitude of electric field at point P, which is at a distance 2r from the axis of cylinder, so this distance is 2r, is given by the expression 23 rho r divided by 16k epsilon naught. And then we have to find the value of k. So if there was no cavity, if we don't remove the sphere from the cylinder, then what will be the electric field at this point? At point P, it will be electric field because of the cylinder. But since we are removing the sphere from it, we have to subtract the electric field because of the sphere. So this is the electric field at point P. Now what is the electric field of a solid cylinder with infinite length? So electric field EC of the cylinder is, we know it is the standard formula, lambda upon 2 pi epsilon naught r. Okay, so if there is cylinder of infinite length and from the axis, if this distance is r, and so this is the formula for this cylinder having a charge density per unit length as lambda. Okay, but lambda is not given over here. Here the volume charge density is given. So how will you convert the volume charge density? Means how will you get this lambda from this rho? Okay, so we know what is the volume of cylinder per unit length. We know what is the volume of cylinder, pi r square L, right? And what will be the volume of per unit length? We will have to divide it by L. L will get cancelled. So volume per unit length of the cylinder is pi. Now R is capital R over here, so it is pi r square. Okay. Now what is lambda? How we define the lambda in terms of volume? It is volume per unit length into volume charge density. Now how we arrived at this? See, what is the volume charge density? It is nothing but Q upon volume of the cylinder. And what is volume per unit length? It is nothing but volume divided by length. So volume will cancel, and what we will have? Q divided by L, which is charge per unit length, which is nothing but lambda. Okay, so volume per unit length we have already calculated. It is pi r square into volume charge density is rho. So we have successfully expressed lambda in terms of rho. Okay, so now we will substitute this formula in EC. So what our EC becomes? Pi r square rho divided by 2 pi epsilon naught r. But what is the r? Since we know it is the distance from the axis of the cylinder, which in this case for point P is 2r. So we will replace this r by 2r r. But you know, sorry, 2r. So this 2 and this 2 will get multiplied. Let me write it again. So it will become 4 pi epsilon naught into capital R. So we have an expression for EC. Now, what is the expression for ES? Electric field because of the sphere. And what is the radius of the sphere? Is R by 2. And it is a straightforward formula. Electric field because of sphere is 1 upon 4 pi epsilon naught Q upon radius square, but radius is 2r, so it is 2r square, and finally it is Q upon 2 square is 4, 4 into 4 is 16 pi epsilon naught r square. Okay. Over here we can also we can also this just get rid of this one r. Okay. Now our expression for electric field at point P is EC minus ES, which is nothing but pi. 1r will still be left over here. R rho divided by 4 pi epsilon naught plus this Q upon 16 pi epsilon naught r square. Okay. Q is a charge on sphere, by the way. But how will you find the charge on sphere? How will you find the charge on sphere? So charge on sphere could be found out easily by, what is the volume of sphere? 4 by 3 pi radius cube r by 2 cube into volume charge density of the cylinder, because we are taking the sphere from the cylinder, so its charge density will be same as the charge density of the cylinder. And so this what we have replaced is this for Q divided by 16 pi epsilon naught r square. So we will simplify it a bit. So pi r rho 4 pi epsilon naught plus, so this 4 and this 16 will have 4, and this 4 and 3 will get multiplied. We will have 1 by 12 r cube rho, this 8, 2 cube is 8 pi epsilon naught r square. We can further simplify this r square, and there will be only r left in the numerator. So pi r rho 4 pi epsilon naught plus 12 8 is 96, 96 r rho divided by pi epsilon naught. Okay, now we can add this to. Please note that this pi will also get cancelled over here. I should have cancelled it way earlier. Okay, and when we add this two, we will have 23 rho r divided by 96 epsilon naught. Okay, but what is the expression given? This. So what we have over here is 96 epsilon naught, and what we have over is 16k epsilon naught. So at the end we have to find k, therefore 16k epsilon naught is equal to 96 epsilon naught. K is equal to 96 by 16. So 6 is the value of k. So this is how we solve this problem. Thanks for watching this video. See you next time.